When you are looking for a word, let's say today in a text, it's convenient to use string find method. But when you are looking for a pattern in a text such as an email address, a URL address, a cell number, a file name, you need more powerful tool. Regular expressions are specialized, tiny programming language which can be used for matching, searching, and replacing strings. The module is called RE. Most of the characters in a regular expression match themselves. There are exceptions to this rule. Some characters are special meta characters and don't match themselves. And this tiny language uses these meta characters to create patterns. Meta characters don't match themselves, and this tiny language uses these meta characters to create patterns. Meta characters are dot, caret, dollar sign, star, plus sign, question mark, curly brackets, square brackets, backslash, vertical bar, and parentheses. Square brackets are used to specify a character class. A range of characters can be created by two characters separated with an hyphen. For example, in a square bracket, A-D would match ABCD. Note that meta characters, except backslash, are not active inside a class. To exclude a character or some characters, start the class definition with a caret, then append characters to exclude. To prevent all confusion with Python string literals, I will use regular expression syntax starting with R, followed by the pattern in single quotation mark. In order to create a pattern, use the compile method of regular expression module. A pattern object accepts also flags such as ignore case, .all, verbose. Unicode flag is not mentioned since it is redundant in Python 3. Now let's move on PyCharm to create our first regular expression pattern. There are two ways to work with regular expression module. I will stick to the first one, which is creating the pattern object first and calling the appropriate method with this pattern. In the second one, you call directly the regular expression method, which accepts two arguments, pattern and string. For example, I create a pattern object with compile method and add a flag ignore case. As the name suggests, it becomes insensitive to upper or lower case. Then call the search method with the pattern. If successful, it will return a match object, and a match object has also its own methods such as start and span group. In the second way, I create directly a match object. I will run the code. Both returns a match object, but with the first one, we will also explore start value of match object, which is 4, and value of the match object, which is 8, span value of the match object, which is a tuple 4 and 8, and the match object's core. The second one returns a match objects, and also it matches core. Regular expression module have some methods, and the most common methods are match, search, find all, and find iter methods. The first one, match, determine if the regular expression matches at the beginning of the string. The search method scan through a string looking for any location where this regular expression matches. Find all and find iter are similar, but find all substring where the regular expression matches and return a list. Find iter does exactly the same thing, but instead of returning a list, it returns an iterator. For example, my pattern is and the text is, this area is halted. I will call find all and find iter methods separately. The first one will return a list, the second one will return an iterator, and in order to get the item of the iterator, I will create a for loop and print the item. And note that every item within the iterator is a match object. I will run, and it confirms that find all returns a list, find iter returns an iterator with items match objects. Backslash followed by different characters creates special sets of characters. It's also used to escape all the meta characters. For example, to match left square bracket, use backslash and left square bracket. Note that every special set of characters created with a lowercase has a version with the uppercase of the same letter, and the uppercase version is the complementary of the lowercase version. For example, backslash lowercase d matches any decimal digit, and its equivalent to the class in the square bracket 0-9. Backslash uppercase d will match any non-digit character. Backslash lowercase s will match any white space. Backslash uppercase s will match everything except white space. Backslash lowercase w will match any alphanumeric character. Backslash uppercase w will match everything except alphanumeric character. Quantifiers are very powerful meta characters. Star, for example, 0 or more repetition of the preceding regular expression, as many repetitions as are possible. Plus sign, 1 or more repetition of the preceding regular expression. Question mark, 0 or 1 repetition of the preceding regular expression. M in a curly bracket matches exactly m instance of the preceding regular expression. M comma in a curly brackets matches at least m instances of the preceding regular expression. M comma n in a curly brackets matches between m and n, including n, instances of preceding regular expression. Star, plus sign, and question marks are greedy. In order to transform them to lazy, add a question mark after a greedy quantifier. Caret matches the start of the string. $sign matches the end of the string. Backslash uppercase a matches only the start of the string, and multiline flag does not change the behavior of backslash uppercase a. Backslash uppercase z matches only at the end of the string, and similarly it is impermeable to multiline flag. Backslash lowercase b matches word boundary, and backslash uppercase b matches non-word boundary. Dot is the joker meta character, and it matches any character except new line. Now let's move on PyCharm and practice. Our objective is to match two successive words starting and ending with a character A. First of all, we have to import regular expression module, and I will create the pattern with the compile method of the regular expression. And in the pattern, I will also add two flags, the verbose flag and ignore case flag. And in order to add more than one flag, we have to use bitwise OR operator. As I add verbose flag, now I can add comments in my pattern. I want that the word has to start with A. First word begins with an A. I create a class of characters A to Z, and I use a quantifier plus sign, which means one or more repetition of the preceding regular expression, at least one character. Another A, word ends with an A. Then \S, which means a white space. Then another A, and second word begins with an A. Again, I use the class A to Z, and I add a quantifier plus sign, which means one or more repetition of the preceding regular expression. And at the end, another A, word ends with an A. And I want to check if my pattern matches Asia, Africa. When I run, it returns a match object, and the match is Asia, Africa. In the fourth example, I want to find all words which are more than 10 characters long in a text. Again, I have to import regular expression module, and I will create my pattern. In my pattern, first of all, as I want to get at least 10 characters long words, I will start to explain it with the quantifier. In a curly brackets, 10 comma, which means that at least 10 of the preceding regular expression, and the preceding regular expression is \W, which is an alphanumeric character, and all of them in a word boundary, because \B is a word boundary. And then I want to find all of the words which are longer than 10 characters long in a text. When I run, I know that find all method returns a list, and it returns me a list of 3 elements: astronomer, observational, and scientific. The last feature of regular expression is grouping, and the corresponding meta characters are parentheses. The contents of a group can be retrieved after a match has been performed and can be matched later in the string with the \number special sequence. \number matches the contents of the group of the same number. Note that it starts from 1 and not from 0. We can name a group with the syntax within parentheses, question mark, uppercase P, and back reference to a named group. We can create a non-capturing group. We can set the corresponding flags for the entire regular expression, or isolate the flag to the group. We can create an atomic group. We can create a positive look-ahead assertion, negative look-ahead assertion, positive look-behind assertion, negative look-behind assertion. Now let me make some examples. In the first one, match 2 same words with or without a white space between them. I create a pattern with the compile method. First of all, I will create a group, alphanumeric characters, 1 or more alphanumeric characters group. Then 0 or 1, white space, then exactly the same content of the first group. And then make a search for 1010 is an hero. In the second example, match Nikola if it is ahead of white space and Tesla. It's a positive look ahead assertion. And my pattern starts with Nikola, then I add positive look ahead assertion, within the parentheses, question mark, equal sign, white space Tesla, and I add a flag, ignore case flag. Then I will make a search. In the third example, I will make an example of positive look behind. I want to match Tesla if it is behind Nikola and white space. My pattern will start with positive look behind assertion, within parentheses, question mark, less than sign, equal sign, Nikola, white space, and then Tesla. And I will search for Nikola Tesla. Fourth example is a negative look behind example. Match Tesla if it is not behind Nikola and white space. My pattern will start with negative look behind assertion, within the parentheses, question mark, less than, exclamation mark, Nikola, white space, and then Tesla. And I will make a search. The brand Tesla is. The last one is an atomic group, and the most important thing is that there is no backtracking. Atomic group will match all the characters without backtracking. Looking for a D after good will match nothing. And my pattern is, within an atomic group, I create a class, character class, God, and I add a quantifier, plus sign, one or more of this. And I will try to match good. I run my code. The first one returns 1010. The second one returns Nikola. The third one returns Tesla. The fourth one returns Tesla again. And as expected, because there is no backtracking, the last one returns nothing. Wrap up. In regular expression pattern, we can create a set of characters with square brackets. We can add a flag. We can create special set of characters, add quantifiers to identify how many repetitions of the preceding regular expression. We can identify the position of the regular expression. We can create group, create named group, and create assertions. Join me on next video for tutorials.